Now let's study how to solve for the root of quadratic functions with Excel solver. So this is actually the same way, same method as we have learned in chapter 1, in week 1. So basically what we need to do here is to first set an x, and then 1 underneath is the actual value of x that you're going to be invoking. And then you will have the left-hand side, which is x squared minus 8x plus 12. Let's do it. X squared minus 8 times of x plus 12. And the right-hand side should be what? Should be 0, because here you're merely solving for the root, right? So then what you can do is to use solver, and your objective is to have left-hand side equal to right-hand side by changing x, right? But here, you need to pay attention to one thing, which is there could be more than one root, right? For instance, this one that I'm choosing is more than one root, as we have learned in our previous discussion. So here, what I'm suggesting to do is still using some of spreadsheet modeling. Okay, you're gonna see there is use for that. Okay, vertex and say root determinant. Okay, so vertex is and here let's put ABC. A equal to 1, B equals to minus 8, and C equal to 12. Okay, so vertex is minus B over 2A is 4. And here root determinant is B squared minus 4AC. Okay, so here it is greater than 0, so there should be 2 roots. Okay, so just working this out will give you a rough idea. And then let's just first do the solver without restriction at all, and let's see what's the result. So here, the solver is that we need to set the objective, which is the function, the left-hand side, which is the function, the value of the function, to be equal to 0 by changing the value of x. Okay, and here the result is 2. Okay, for my cells, let's change that into just number. Okay, when x equal to 2, left-hand side equals to right-hand side equals to 0. Okay, that's the root here, as we previously solved out. So then your question could be, hey, solver can only give me one answer, and here is the default answer that solver gives you. So here you can see the use of vertex. Okay, so you can tell solver now, okay, by imposing a constraint. So the vertex is the symmetric axis, right? It's a symmetric pixel. So pivot. So what we need to do is, here we've already found the first root, and then we need to find the second root. And here we are just, what we do is x being smaller than 4, which is a vertex, and let it solve. So that should be one of your root, which is 2, right? And then do it again. Change that into the other case. Just select this constraint. Okay. delete that and add a different constraint. So now the constraint should be, what if x is greater than 4? And then it should give you the other result. Okay, so here, when there are two results, two roots, add constraints as x smaller than vertex and x greater than vertex to find the two roots. Run solver twice to find the two roots. Okay. And it will be clearer later on as we are doing the graph. Okay. So here, this is the first case. The second case is this one. Okay. And as we previously solved out, this one, function 2, has no root. So let's just test it out. X, we have left-hand side, which is the functional value, right-hand side, which is 0. Okay, what we need to do is, all right, we let left-hand side is x squared minus 8 times of x plus 20. Okay, what we do here is, all right, we are we're trying to change x. We're trying to change x so that left-hand side equal to right-hand side, which is 0. Hit solve. Cannot. Yeah, selected that again. Hit solve. As you can see, it actually doesn't hold, right? So that's why this has no solution. And you can verify by go to the root determinant again. So here A, B, C, where A is 1, B is minus 8, and C is 20. And your root determinant is B squared minus 4AC, which is smaller than 0, no root. And here, yes, solver has tried its best, but cannot, right? Actually, x equal to 4, that's the minimum value of this function, but still the functional value is not equal to 0. Okay, let's go to the third one. So the third one, again, let's set it up, x, and here the value underneath, and left-hand side, which is the function value, right-hand side should equal to 0, and the function value is x squared minus 8x plus 16. Okay, so now first let's run it. Solver. Okay, what we need to do is left-hand side equals to 0 by choosing x. That's exactly 4. And here you can further verify. So vertex is A, B, C, where A equal to 1, B equals to minus 8, C equals to 16. So vertex is minus B over 2A, which is 4. Okay, and then also you can do root determinant, which is b squared minus 4ac equal to 0, only one root. Okay, we should add the quotation mark telling it it's not, the equal sign is not calculation. Okay, usually as you're adding equal sign, then you need to calculate using a value of cells. But here it's just to demonstrate. Okay, so there is only one root, and that's 4. And here you can also double check by adding constraint. So x is smaller equal to 4. That's this result. And then change that into greater equal to 4. That's the same result. So it tells you there is only one root, which is x equal to 4.